Okay, in this video, we're going to look at proving trig identities for grade 12. Okay, first we need to look at some known identities. All right, so we have these ones from grade 11. Okay, so the first one is tan theta equals sine theta over cos theta. And then the reciprocal of that, so just flipping it, 1 over tan theta is cotan theta, is cos theta over sine theta. Okay, if you want to review this, you can look at my grade 11 videos on 3U trigonometry, trig identities, and it'll show you why this is true. Same with this one. So sine squared theta plus cos squared theta equals 1. This is the Pythagorean identity, and this is proven again in my 3U videos. Now, if you take both sides of this and you divide the whole side by sine squared theta, well, this side here, so sine squared over sine squared is 1. Okay, cos squared over sine squared, well, cos over sine is cotan, so that's going to be cotan squared. And then 1 over sine squared is cosecant squared. Okay, so if you divide both sides by cosine squared, then you get this one. Okay, so that's where the grade 11 trig identities come from, or what they are. Now the grade 12 identities, we have a lot bigger page here on this. So we have the compound angle formulas. So I've shrunk them down here a little bit. So I put a plus or minus in here. So this is plus or minus here. The pluses on the top correspond and the minuses correspond. For the cosine one here, the plus corresponds to the minus up here. So if you're using a plus b, then there's a minus in here. A minus b, there's a plus here. Okay, and here's the one for tan. Okay, so those are identities that we need to know. And then we have the double angle formulas. So these are identities as well. So sine 2a equals 2 sine a cos a, and so on. So we have all these double angle formulas. If you need to pause the video to review them all or write them down, then you probably should, okay? So those are our 3U and 4U trig identities that we can use. So now we're going to jump right into proving an identity. Okay, so I'm going to go to some that are out of the textbook, but I will write them out here for you. Okay, so first one is going to be they're on page 417. Okay, and we're going to look at 9C. Okay, so 9C, it says to prove that tan squared x minus cos squared x equals 1 over cos squared x minus 1 minus cos squared x. Okay, so you can start from one side or start from the other side. You do not prove these by keeping the equal sign here and working down both sides. Okay, so what we want to prove is equality. So we want to prove that they're equal, so we can't state right away that they are equal. So this is, to prove this, we need to start with left side equals and figure it out, or right side equals. I'm going to start with the right side for this one. Okay, so the right side equals, so you rewrite it, 1 over cos squared x minus 1 minus cos squared x. Okay, so there's a few things you can try and do here. One would be to try and get a common denominator. So multiply the top and bottom of these by cos squared. So you have cos squared as the denominator. I want to get tan squared minus cos squared. I already have a minus cos squared here. So those two pieces are the same already. So maybe I just want to play with this and see if I can turn this into tan squared. So I'm just going to get a common denominator for these two. Okay, so that equals 1 minus cos squared x over cos squared x minus cos squared x. Okay, so I multiply top and bottom of this by cos squared, and then I have a denominator of cos squared. Now we know that 1 minus cos squared from our identity list equals sine squared. Sine squared x over cos squared x minus cos squared x. Okay, and at this point, we know that sine over cos is tan, so we're going to replace that with tan squared x and minus cos squared x, and that equals the left side right there, and therefore left side equals right side. Okay, we can write that out completely, but I'm just going to save some time right now. Okay, so that's 9D. 9C. Now we're going to do 9D. Okay, so 9D, this is the identity here. So 1 over 1 plus cos theta plus 1 over 1 minus cos theta equals 2 over sine squared theta. So that's what we want to prove. Don't know if this is true yet. They're saying to prove it. So I'm going to start with the left side. So left side equals 1 over 1 plus cos theta plus 1 over 1 minus cos theta. I'm now going to get a common denominator. And I'm going to go, so to get a common denominator, I'm going to multiply these two together. I'm going to take this, multiply it by 1, this, multiply it by 1. So I'm going to get 1 minus cos theta plus 1 plus cos theta all over 1 plus cos theta, 1 minus cos theta. Okay. And now I'm going to put this together here. So on the top, I'm going to have 1 plus 1, which is 2. Negative cos theta plus cos theta is 0. So the top is just going to be 2. And the bottom, I'm going to multiply that out. Okay. So I'm going to multiply that out. So 1, this is a difference of squares. So when you multiply this out, you're going to get 1 minus cos squared theta. You can check that out. 1 times 1 is 1. 1 times negative cos theta, and 1 times positive cos theta. Those cancel out. And then cos theta times negative cos theta gives me cos squared theta. Okay. Now 1 minus cos squared theta is sine squared theta. So 2 over sine squared theta. And that equals the right side. Okay. So therefore, left side equals right side. Okay. And that's that one proved. Okay. So the next one we're going to look at is same set of questions, 10B. Okay. So 10B. B says sine squared theta plus cos to the 4th theta equals cos squared theta plus sine to the 4th theta. So that is what we're trying to prove. So in this one, we're going to start with one of the sides. I'm going to start with the right side. Just as easy to start with the left one in this one. So right side equals cos squared theta plus sine to the 4th theta. I'm going to replace sine to the 4th theta with cos squared theta plus sine squared theta squared. So that's the same thing. Okay. And now I'm going to write sine squared theta as 1 minus cos squared theta. So cos squared theta plus 1 minus cos squared theta squared. okay? And then I'm going to expand that out. So when I expand that out, I still have cos squared theta at the beginning, plus 1, it's a perfect square, so minus 2 cos squared theta, okay? So when you write that as two brackets, it's going to be 1 times negative cos squared theta, and 1 times negative cos squared theta, which gives me 2 of them. And then negative cos squared theta times negative cos squared theta is positive cos to the 4th theta. So when you expand that out, this is what you get here, okay? Now, a cos squared theta and negative 2 cos squared theta, that gives me 1 minus cos squared theta. So I collect these two together, it gives me 1. Plus cos to the 4th theta, and then 1 minus cos squared theta, that equals sine squared theta. Plus cos to the 4th theta, and that equals left side. Therefore, left side equals right side, and we're done that one. Now what about 10e? Okay, so 10e. Let's take a look at this one. So we're now into some grade 12 stuff, okay? So this here was all like grade 11 trig identities, okay? Now we're looking at some grade 12 stuff. So sine pi over 4 plus x plus sine pi over 4 minus x equal to root 2 cos x. Okay, so it looks like I should start from the left side because the right side's much simpler looking. Okay, so that's what we want to know. So left side equals sine pi over 4 plus x plus sine pi over 4 minus x. And we're going to use the compound angle formulas here. So sine, the addition is sine cos plus cosine. So I'm going to do sine pi over 4 cos x, that's for this one, plus cos pi over 4 sine x. Okay, that's all for this one being expanded into that. Plus, this one becomes sine pi over 4 cos x minus cos pi over 4 sine x. Okay. Now, I have 2 sine pi over 4 cos x, and I have these ones which cancel each other out. So those cancel out, and I'm left with 2 sine pi over 4 cos x. Now, sine of pi over 4, we know that that is 1 over root 2. So 2 times 1 over root 2 cos x. Okay. Now, if I try to rationalize the denominator here, I'm going to multiply the top and the bottom by root 2. And that's going to be, that's equal to 2 times root 2 over 2 cos x. Those cancel out, and I get root 2 cos x, which equals the right side. Therefore, left side equals right side.